Hola, ¿cómo vocês estão? Okay, thank you. Yeah, that's it. That's almost all the Portuguese language that I know. Yeah, so, let me set the screen for a bit. I should make it into a mirror built-in. Cool, now you can see my screen. Okay, so today I'm going to talk about modern web debugging and share some features in Chrome DevTools that you might not know and could be useful for your daily development. So here is the first tip for you. So you see like this, oh, not this, okay. So you saw this screen, right, in the console. This part, this is a real printout. I'm doing a real screenshot. And you can do this as well. The way that you do it is that you can have CSS style. If you define a constant called style and then put in your CSS style, what you can do is when you console.log your value, you can put a %c here. So %c means that you are passing in the style to style the message. That's how you can style this message. So if your website wants to have some cool recruitment message, you can use this way. Okay. So yeah, it's actually, this time is my first time in South America, and I find it amazing. Your food is delicious, okay? Yeah, and this is the first time I actually eat rice with potato fries, because usually we just eat either one. We don't eat everything together. And also your McDonald's sell the pão de queijo. I like that, but the McDonald's in my country don't have that. Yeah, so this is amazing. Cool. Okay, some of you, if you see me before, you might have seen me before if when you open DevTools, sometimes you might see this what's new tab that is popping up every now and then. If you don't close that, you click on one of the link, you might see the video or the article that I write to talk about some of the new features in DevTools. But that is in English because I don't speak Portuguese. So if you want to learn new features in DevTools, you can also click on those links to learn like what are the new features. It comes every month. Okay, now let's go to the main topic. We talk about debugging modern web. What is modern web? What is the old web? Let me show you this. So this is the Chrome DevTools in 2009. This is 16 years ago. At that point of time, it's okay. We only have 4 panels. You have elements panels and resource panels and others. This is fine. Now, fast forward to 16 years later, this is the Chrome DevTools nowadays. Can you guess how many panels do we have? Okay, let's take a guess. Who guesses like less than 10? Less than 10 panel? Okay, one person. Another one here. 10 to 20 panels? 10 to 20? Okay. More? 20 to 30? Okay, slightly more. 30 to 40? Okay, some hands. Oh, keep raising your hand. You are right. But let me just ask you, can you guess how many panels exactly is there? No? So overall now, DevTools have about 33 panels. But maybe the one that you use daily, just 4 or 5 of them. But we have 33 panels overall. This is amazing. And all the panels is hidden under the 3-dot menu, more tools, and you can see the list of it from here. Okay. Though after since 16 years in DevTools as is, the browser actually doesn't change much. The browser still mainly understands HTML, CSS, and JavaScript. Although the browser also understands WebAssembly now, but HTML, CSS, and JavaScript is still the main language that people use today. The way that you develop web application is so much different now. You use different language because you don't like HTML, you don't like CSS, you use Sass, you use TypeScript, you use Pub, and you use different frameworks like Angular, React, Vue, and you use meta framework like Next and Nuxt. How many of you are using framework for development? Cool, almost the full room. How many of you don't use any framework? Oh, I saw a hand there. Okay, I need to give a clap to you. Bravo, okay. Yeah. So there's so much changes, but the browser just understands HTML, CSS, and JavaScript. That's why you need build tool in between, like with Webpack and Rollup. You need these two in between to translate your code into something that the browsers can understand. But what about debugging? Debugging is the other way around. So you tell the browsers, you transform the script to the browsers, but now you need to debug your code. But you don't want to debug the JavaScript that is translated. You want to debug the TypeScript that you are writing, right? So how about debugging? Is that improved after this 16 years? And to be honest, debugging is important. This is us most of the time. You code for maybe 6 minutes, and then you stuck in debugging for 6 hours, and maybe it's just because of one line that's going wrong, then you spend so much time there. So debugging is an important topic. So let's take a look at this example and see how we can debug that. So let's say you have a very simple counter applications. If you click on the plus sign, and it throws an error. So what do? You open the console and check what is the error. And then from here, what you can see is that, you see that, oh, it tells you that the app component.ts file, TypeScript file, line 27, have an error. And then from here, you can click on the link. And once you click on the link, you can set the breakpoint and then do the same action again. And then you can step into your code and then start debugging what is actually happening. And then now you might say, oi, Jecelyn, I thought you say browser do not understand TypeScript. But just now, I'm showing you the TypeScript code. Hey, why the screen? That's interesting. Okay, something wrong with the... go back. Yeah, okay, go. Okay, so you must say that, oh, Jecelyn, you say that the browser doesn't understand TypeScript, but just now when I show you the line of error, it's showing you the TypeScript. So what is happening there? So I did not lie. If you look here, it's actually tell you that this file, this TypeScript file, is originated source map from a file called main.js. So where does this main.js come from? Where does this source map come from? So apparently during your build process, when Webpack and Rollup generate your file, it can generate one more file. It is called the source map file. So this source map file is what the browser used to understand your code. So let's look here. This is an example of a source map file. So first, you have the file name here. So this main.js.map file is belong to this main.js file. And then from here, this file is like a JSON structure. You can look at the sources here. It says that this file is actually a combination, a minified file of these two TypeScript and the JavaScript file. And then each of these files, these are the whole JavaScript file, the content is straight away put inside this source content properties here. And then the next thing what we do here, you have this mapping field, which is a base64 VLQ string, which is like the, in like our map, as the longitude and latitude is telling you that how do you map this file from the minified file to the origin file. So let me show you how it works. So for example, like this is the source map VLQ string just now, the mapping field. This is your minified code. Everything is in one line. You have this random grid function. And then this is your original file, which is multiple line, not yet compressed. So now, let's go through this AAAA. AAAA stands for 0, 1, 0 when we read that. So what is 0, 1, 0 means? So 0 means in the minified file, position 0 is where you should start counting. And then the 1 and 0 is your original file. Line 1, position 0. So this is how we try to map your minified file to the origin file when the browser read that. And then now the next question is, how do you know how long? You just say that where does it start, but where does it end? So now we say that it's end in function and a space. How do we know when to end? So this is the next mapping, SAA. So means 9 to 19. So since it starts from 9, that's why the previous mapping should end at position 8. That's why we know that it's end at the function. So this 919 means random grid. The random grid starts from position 9 in the minified file, and then it's mapped to the original file, line 1, position 9. And using the same logic, this is the last one. You can go to like position 23, map to line number 2, position number 2. So this is how browser will use this file to process and do the mapping from the minified file back to the TypeScript file. And that's how we can tell you that. Oh, the error is happened in your TypeScript file, line 27, although the actual error is in the JavaScript file, maybe line 49, for example. So this is how browsers understand that. If you want to know more about this topic, you can go to I have a video to talk about what are source maps. And you can also go to Eric. You know Eric, he has a talk tomorrow as well. So he also have a video to talk about how to create the minified processor from the scratch. So you can go there to learn more. Okay, next, I would like to talk about how DevTools use source map to help you pinpoint the issues quicker. So before that, this is how you debug. So when you start debugging, you can see that from line number 1 here is something that is not your code. It's zone.js, it's something from the library. Maybe you are using React, and then this code might be from the React. And then only like when you go down, maybe 200 lines later, and then you found that the error is happening in your component. So, but this is not what we want. What we want is that we want to straight away see the errors in our code, not the library code. So now, DevTools actually hide irrelevant stack trace from the stack trace, and it's also hide irrelevant core stack when you are debugging. You can also view your code first and hide irrelevant file. Let me show you a live demo on that. Okay. So here, this is the same demo. Let me refresh it. So when I click on this, let me zoom in slightly more. Okay, I think it's slightly better now. So when you click on that, if you expand it now, you see that all you can see is your code. You see that the errors happening in app.component and button.component and main.ts. This is all the file in your source directory. Before that, let's see here. You see DevTools actually already help you automatically hide 236 lines of framework and library code. If you expand that, you can see that zone.js instrument, all these files are inside your node modules, which you don't want to debug that. So now by default, DevTools will hide that. If you want to see that, you can still click and then see it. And then the same when you are debugging. So let's say now I'm in my app component. And then let me just click here. So when I click here, in your core stack here, you can also just see whatever file, whatever things that in your file. And we also already ignores a lot of things. So if you want to see them, you can click on here, expand. From here, you can see whatever things that is in your framework and library. But most of the time, you don't need that. Okay, so the next thing that is here is that in your code here, you can see that this is the minified file, your JavaScript file, and then your actual TypeScript file is hide under the Webpack, and then build to, and then your source. This is your TypeScript file. So sometimes, if you want to see your TypeScript file first, there is one setting here. If you click on this three-dot menu, you click on this group by authored and deployed. So what you can do here is once you group, you switch the sequence. You can view your TypeScript file first from here. You can here, yeah. TypeScript file first from here in the source panel. And then whatever deployed file, the minified file, we just push to the end so you don't have to see them. And if you see here, DevTools also already hides the things from the Webpack. And then if you see another one here, the node module is also gray out. That's why all the file is hidden. If you say that, oh, I don't want to see this in this tree, what you can do is you can click on this three dot. You say that hide ignore listed source. Once you click that, we hide the node modules as well, so you don't see them at all if you want. So these are the different settings that you can play around to hide and then to group by the folder, which is quite convenient. OK, now, how DevTools know what to hide? Because just now when I show you source map, I only show you how DevTools map the file. I did not show you how actually DevTools know what to hide. Why do we hide something inside the Webpack? Do we have AI behind the scene to do that? No. So DevTools actually use source map to know that what to hide. But this is the thing that the browsers, the framework, the build tools need to let us know. For example, let's say the second line is the node modules observable. This is the file from the library that you don't want. There is another field here called X Google ignore list, and it's put the position of the source variable. It says that this file, let's hide it by default because developer usually don't want to debug it. So framework needs to tell DevTools when they compile the code into tell DevTools that this is something that we should hide. The good thing is Angular, Nuxt, and Vite already configure this out of the box. You don't need to do anything. So if you're using Angular, Nuxt, or Vite, this is already done for you. So, but if you have extra folder, like if you have something from the Google Analytics or you have a third-party asset folder that you want to hide it by default during debugging, the stack trace, you can configure that as well. These two have a field called source map ignore list that you can use it to configure what you want to hide. So let's take a look at this rollup configuration file. It's the same in the Vite configuration file. You can use this as well. So what you can do is that you can, in the source map ignore list, you need to tell like, what do you want to hide? In this case, I want to hide everything that has the path of third-party asset. So anything here will just hide by default. And if you, let's say you have more than one folder, you can just specify that and then hide it by default. That makes your debugging slightly easier. And Firefox also support this X Google ignore list settings too. So if you're a Firefox user, in your setting, you can click on that and then select the ignore, the ignore setting. So you might be wondering, it is called X Google ignore list. Why Firefox support that? Because Firefox see the value inside it. That's why it support that. Okay, next. Who is using React here? React users? Okay. So just now in my slide, I did not mention React. So what if my toolchain, if you are using React, doesn't support the ignore list yet? How can you do it? So you can do nothing. So by default, DevTools now also hide the node modules. And then you also have an option to hide the files or folder manually, and they will be grayed out visually. Let me show you what do I mean. So for example, I'm inside this application. So I did not do anything. But inside here, actually in DevTools, there's a setting here called ignore list. So by default, DevTools already add this custom exclusion rules. And then we say that everything in the node modules and in the bower component, we will just ignore it by default. So by default, it's checked here. So you don't need to do anything. So let's say you are using React. Your node modules will be hidden as well. But let's say you are doing debugging. So let me set a breakpoint here. Event listener breakpoint. And then let me go to mouse click. So now I set a breakpoint. So if I click on this item here, it will straight away jump to the list the view file and not jumping into anywhere else. And then, but when you debug it, you go one step and then one step again. Let me just go. And then you see at some point, it jumped to this Google Tag Manager. It jumps to this file where maybe you don't want to debug that because this is the file that is from the analytic. You might have some other analytic library. So what you can do now is that you can right-click on this folder, and then you say, add this directory to ignore list. So once you add that, the next time if you do the same action again, and you debug again, we won't jump into the JS, the analytics file again, because you choose to ignore that. So you can ignore any file or any folder. And if you want to unignore that, you can right-click and then remove it from the ignore list again. Then you can debug and step into it. Cool. OK, next one. Maybe a lot of you see this warning before. Have you seen this? DevTools failed to load source map from some extension and then a list of warning error in your console. Anyone see that before? Yeah, a lot of you see that before. But if you upgrade to the latest Chrome DevTools, these are gone. You won't see this anymore because DevTools by default will not show any source map error in your console because this is not the thing that you can fix. For example, if you install a lot of Chrome extension, the extension usually throw this error, and you cannot fix the extension to ask them to add a source map. So now we don't show it here. So you have a cleaner console now. So, but if you need them, we have another panel called Developer Resources panel. If you want to debug your source map error, you can come here, see the list of source map that is loading, and then check the error. Or if you are debugging, DevTools will show that source map warning when you're opening the file as well, like this one. OK, next, let's talk about some challenges in fixing debugging experience. Source map is great, like I showed you just now, but source map is not perfect. And so for example, let's take a look at this random greeting example. So in this function, I have two variables. One is the number variable, one is the greeting variable. So look at the greeting variable is a static string of hello. And then we use both of these to put that into the paragraph inner text, greet and number. Now you use with or you use any bundle to build the file, minify it. This is your output. So everything becomes one line. And you can see that, oh, the text becomes hello E. We still have the E, so E is your number variable, minified to E. But the greet variable is gone. When you build it, it is smart enough to know that, oh, that is a static string, and you only use it once. Let me just embed it straight away in the output, so that it's safe, it's better for your performance. This is good for performance, but this is not good for debugging. Why? Because here, if you are debugging, if you look here, DevTools can show you like the number preview, show you that what is the number. But DevTools is not able to show you the greet variable because the variable is completely gone in the final file. And you are not able to see it in the local the local scope here as well, so you cannot edit it. So this is not great. And to be honest, source map, the specification, It's not an official standard. It is unofficial that everyone uses. And source map spec is in version 3 since 2011. 2011, there's no TypeScript. There's no SASS, maybe. There's nothing. So since this 13 years, it never changed. So everyone is still using the same format. And the source map spec is very flexible. Like a lot of things, it did not specify that, oh, when should you tell us that what is the variable, like how can we map it? It is very flexible that it did not state like how to do certain things. So every browsers and every build tools do it differently. Like Webpack do it differently, Rollup generate the file differently, ESBuild generate the file differently. So this make, when you debug your code in different browsers, you might have a different experience. That is why, because the spec did not state how to do a certain thing. So since last year, we are starting to standardize the source map, make it an official standard. We are working with TC39 in order to spec this. And the source map is, the goal is to evolving the source map, harden the spec, and improve the debugging experience. If you want to follow the discussion, you can click on the link to follow the discussion today. And this is not something that just the browser need to do. This is about the ecosystem. Like the build tool need to be able to generate the source map file correctly, consistently across tools. The browsers, DevTools, Firefox, Chrome need to read the file consistently as well. And the logging tool, like Sentry and other logging tool, they are also depends on the source map file to tell you where the error generate from. So they are also the users of that. And the transpiler and the compressor, like the minifier, also need to generate the file correctly as well. So this is an ecosystem-wide effort that we put in to improve the debugging experience of everyone. Cool. Now come to the last part of my presentation. Usually, this is the part that people like the most. So if you like, so I will share you multiple tips. If you feel the tips that is useful for you, you can give me a clap. Okay? Okay, let me drink first. Okay. All right. Okay, first, this is the first tip. I really like these features. It's called override HTTP response header. So in DevTools, you can now do that. Why is it useful? Let me refresh this page, and then I show you why. Cool. Wait. Okay. Refresh again. Hello, where's my error? Okay, yeah, it's here. Slightly late. So here, the blah, 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 blah is failed. This has been blocked by course policy. No access control origin header. Anyone hit this error before? Yeah, everyone. I hate this error a lot. So sometimes we know what happened. So usually it's the server side, something in your server that someone needs to configure that. Let's say you are a front-end developer, and then you tell your back-end developer, hey, this API is not working. Can you fix it because I have this error? And then the back-end engineer say, oh yeah, let's just wait, tomorrow I will do that. But this actually stopped your development. So what you can do now is that you can change the header within DevTools, locally, and then to override it temporarily until the backend fixes the error. So this is how it works. So you go to the network tab. So this is the field request. So you can right-click on this one, and then you can say there's an option here called override header. Click on that. You will open this file. And then from here, what you can do is you can click add header. And then you click access control allow origin, add this. And then what you add, let me just add everything, okay, just for simplicity. So once you do that, that's it. Now we do that for the to-do JSON. If you refresh that again, see, The to-do now has the list. Yeah, this is good. So you can tell your backend engineer, okay, take your time. I can continue my development now. Okay, so you can do the same. You can do the same like we haven't fixed the dummy JSON yet. So you can do the same. You can right-click and override the header as well. But we can do something better. So actually, just now when you are creating this, right, we are creating a local file, .header files in your local drive. So if you click on that, you can open this. It will say that it's applied to do JSON, and it's like access origin all. So this one, it actually accepts wildcard. What you can do here, you can say that everything. So then you can refresh it again, apply to everything. Now your to-do and your dummy JSON is loaded. Yeah. Cool. This is really cool, right? And to be honest, this is not only for like this cause error. Imagine that you have some cache header, or you have some other securities header that you want to test. You can use this. Like sometimes you want to test your iframe, you want to limit the security, like the permission. So you can use this to override and test the permissions of the iframe access without going back to the server, change again, come back and change again. So you can test this one in DevTools first before doing that. All right, so this is the first feature. Now, the second feature, you can mock API and file content as well. Just now we show you how to mock the headers. This one is something like Postman. You can mock the API and the files content. So how do you do it? Okay, let's say now I have this coffee. Wait, I don't want to debug anymore. Let me just disable that. Okay, so let's look at this network request in the fetch. So I have this list. Sometimes, maybe like the backend API is not ready yet, but in this case I'm ready. So let's say the backend API is not ready yet, but you know the structure of the JSON already. So what you can do is, you can right-click here and say that override the content. So once you override the content, DevTools will copy the file. And then what you can do here is that, oh, I don't like the name Espresso. I want to change the name to Brazil Espresso. Okay. And then this is too expensive, like 30, the quantity, the price is like 10. I want to change the price to 5. Okay, I can save it. Any API will work. So if you refresh that, you see now? Here become Brazil Espresso and $5. That's so easy. But yeah. And this one is especially useful when you are doing production debugging. Imagine in the production, right? You cannot change the production API. But maybe you have some typo in the API in production. You just want to quickly test in the browsers before you make the changes. You can use this way to test and then to do that. So this is very convenient. So use this. Okay, yeah. So this is second one. Next, this is a feature I really like as well because I built it. So this is called emulate a focus page. So look here. I think here, like, let's say I want to search something. So let's say now you want to debug this drop-down. And then what you do is that you right-click, and then you click inspect, correct? And then it's gone. How many of you have this experience before? How do you debug it? Maybe you go and change the JavaScript, or maybe, okay, because I use DevTools, right, I can do something better. So I inspect. Oh, it doesn't work. I guess maybe it's the hour. So I can click on this. I will click on hour, and then hour again, and then I right-click, and then try to do the same thing again. But it actually doesn't work. Like the hour doesn't work. Then what I do is that I just check everything, and I right-click, and I do the same thing again. No, it still doesn't work. Okay. So what is the reason? So we need to understand like there's many ways to show and hide stuff. Very commonly, this drop down and this disappearing element is using something called document focus. So they use the document, the focus state, to determine whether we want to show and hide the thing. It's not depends on the element, but it depends on the document. So if you use here, you can see that DevTools actually have a new checkbox here. It's called emulate a focus page. So what we are doing is that every time when we right-click and inspect, we lost the focus on this page. The focus is now in DevTools. That's why it is disappear. So what we want to do is we want to put the focus back to the page, even though we go to DevTools. So you just need to check this box, and yeah, it will just show, and then you can just do the debugging here. Okay? So make sure you check this checkbox, and it will help you. Okay, I still have 4 minutes. Okay, now this one is called record, replay, and share. This is actually a feature I really like as well, and I have a video tutorial on that. So what you can do is that you can record the screen action. So click on this 3-dot menu, more tools, and recorder. So from here, what you can do is you can create a new recording, and I call it order a coffee. Then I start recording. So I can click on the item, I can click on it, and then I can put my name, and then check it. You see that it captures every step that I do, and then I stop the recording now. Cool. So now what I can do is I can replay it. See, I can replay the step on the screen and will repeat. And maybe you think it's too fast. If you think it's too fast, you have the option to like play it slowly, very slow, or extremely slow. Or you can set a breakpoint as well. Like here, I will set a breakpoint here. So when I replay, it will just stop at this step before the click. And then if I say play one step, you see that it's actually clicked on the item, and the cut is actually +1. And then go to another step, add again, check out. So this way, you can, if you are debugging, if you are repeating, want to reproduce the bug, you can record it and then replay it. Yeah. So this is very convenient. Yeah. Cool. Yeah. And this one is really useful. Sometimes, right, it's useful when I debug a shipment form. There are multi-pages form that you need to fill in. And every time you need to fill in order to go to page number 3 to finish to find the bug, right? So you can use this to replay it until step number 3, and then start to debug your actual file. So you can use this feature to do that. Okay. Do we still have time? Okay, I have 2 minutes. I share you the last tip about performance. So this is not just something in DevTools. This is something that you can use to improve your performance. This is a new API. So it works like this. So for example, I have this page. So what you can do is you can set a style called speculation rules in your page. And let's say, for example, in your page, I have these few pages. I have apple, orange, kiwi, and other page URL. And then from here, you can set like setting here called pre-render, and you pass in a list. The source is a list. So this is the list. You pass in apple, orange, and kawa. This is a typo. It should be kiwi. So what you can, so this one, basically, this is how you set it. So if you go to the page, this is a new API in the web that you can use. It's called speculation rule. You put in a script called type speculation rule. You put in this thing. So what this will do is that when you load this page, load already. When you load this page, DevTools will preload the apple page, orange page behind the scene. So when you click on that, DevTools will browse to the file immediately. Not DevTools, sorry. The browser will go to the file immediately so that your performance is faster. So you just need to do that. And then in DevTools, this is how you can debug it. So you can debug it. So this is your current page. So apple.html is the page that's pre-rendered. You can click on this to check like what is the pre-render file that DevTools generated. here. So this is a very good way to improve your performance. And not only here, in the application panel, you can also see that. So if you go to the application panel, speculative load, from here you can see that DevTools actually preload 2 pages and 1 is failed. So from here you can see that, oh, the apple.html page DevTools pre-rendered behind the scene earlier for you, orange as well. And for the Kawa, because the page is not assist, it's called Kiwi, then DevTools will show you like this error. Yeah, and even better, if you have like, you can set the pre-render rules to do like something more dynamic. Only when you hover over some link, and then you will trigger the pre-render. So let's take a look at here. Speculation rules. So now this is my setting here. And let me go to this when I hover to the, refresh. Okay, cool. When I hover to Apple, white. One ready. Okay, yeah, here. So everything is not triggered. Let me hover to avocado, because the second one, avocado. So now if I hover to avocado, you can see that it's actually tell you, it's actually start to pre-render only when you hover over it. Like orange is ready. And then if I hover to kiwi, kiwi is ready. So this one is like you pre-render the page ahead of time when the user hover over the link. So this is quite useful if you want to render the page dynamically. Okay, cool. All right, almost time's up. Okay, cool. This is the DevTools in the old time. This is the DevTools in 2024. So what is the DevTool will be like in 2034? I don't know. Maybe something AI, because everyone is doing AI now, right? So we don't know. But if you can, please help me to fill in this survey form. And I also put in my presentation link there as well. And if you want to talk to me, I will be there later on. And you can find me in Mastodon, LinkedIn, and Twitter. Please help me to fill in this form so next time I can come back to Brazil again. Yeah, okay. Obrigada. Thank you.